In this video, I will guide you through the process of building a fully functional Flutter application. The app will consume a REST API to retrieve a list of upcoming movies. By following this tutorial, you will learn the following: how to use solid patterns to consume a remote API, how to implement the repository pattern to create a local cache of data retrieved from the API in a local database, how to develop a mechanism to detect new data from the API and flush the local cache to download the updated data, how to create an infinite scroll list to display the retrieved data as the user scrolls. To implement the functionalities I have described, we will be using some powerful libraries that will enable us to reduce development time significantly. To create our domain layer models, we will be using the Freeze library, which works seamlessly with Dart classes. We will simplify the process of defining our data layer models using JSON serializable. For making requests to the remote API, we will be using the DO library, which streamlines the process of consuming a REST API. We will be using SQFlite for the database and learn how to implement the repository pattern to adhere to the clean architecture standards. Finally, for the infinite scroll functionality, we will be using the infinite scroll pagination package. This tutorial is designed for individuals who are new to Dart and Flutter, but already have a basic understanding of these technologies. I will not be covering the fundamentals, such as variables, functions, classes, or Flutter widgets. Therefore, you should have a solid foundation in these basic concepts before beginning this tutorial. I will be explaining the basics of clean architecture applied to a Flutter application. While I will not be strictly adhering to the principles, I will be sharing the adaptation that I have been using for many years in my own apps and those of my clients. I encourage you to observe closely and listen carefully in order to improve your learning process. The complete source code for this app is available along with helpful links to the tools that I will be using in the video description. Let's get started with the tutorial. Let's begin by creating a Flutter application for both Android and iOS. Once created, you can open the project in your preferred IDE, either Android Studio or VS Code. For me, I will be using Android Studio since it's the IDE that I'm most familiar with and have been using for many years. The first step is to open pubspec.yaml file and remove all the default comment blocks. I'll also remove the Cupertino icons package since it's unnecessary. Next, I'll remove Flutter lints and instead install the lint package. This step is optional, and you can still follow this tutorial with Flutter lints if you prefer. However, if you choose to use lint like I did, you will need to modify the analysis options.yaml file accordingly. To ensure that the configuration is correct, you can run Flutter Analyze. I'll also remove some content from the test file to prevent it from interfering with the output of Flutter Analyze. Moving on, the first thing I'm going to do is to create a model that will serve as a representation of a movie. However, before doing that, let's take a moment to examine the API that we'll be using. You can find the link to this page in the video description. We'll be using an endpoint that returns a list of upcoming movies. If we take a look at the response JSON, we can see the data that's returned. For this tutorial, we'll only be using the movie's identifier, title, image, and release date. One of the fundamental principles of a solid architecture is that each layer should have a distinct responsibility and should be decoupled from the others. This means that any change made to one layer should not affect the rest of the layers, reducing the potential for failure and improving maintainability. To achieve this, we will create a movie model that meets the requirements of our application and aligns with the business rules that govern it. This should be done independently of the API response. Next, we will create an entity that accurately represents the data returned by the API. Finally, we'll create a class that converts the API entity into our domain model. One option to create the movie model is to use a Dart class, but there are some utilities that are not available by default in Dart, such as methods to duplicate objects and comparison methods. These utilities should be present in any language. To address this, I will use the Freeze package, which generates these utilities automatically. I will follow the installation commands provided in the freeze documentation and create a domain directory, with a models directory inside where the domain models of my application will reside. Next, I'll create a file called movie.dart and define the class with its properties. Note that this class includes the freeze annotation and extends another class, among other differences from a standard Dart class. This is all explained in the freeze documentation. My movie class will contain the movie identifier, title, an optional image, and release date. Finally, we need to auto-generate the freezed files to provide us with the additional functions. I will document the autogenerate command in the README file. Running this command will result in a new file being auto-generated with all the extra functions I mentioned earlier. My next task is to create the network layer. To achieve this, I will make a directory named data and then create another directory inside it named network. Within the network directory, I will create another directory named entity, which will host the network models. These models are classes that precisely represent the content of the remote API responses. To create the network model, I will create a file named movieentity.dart. I will utilize a web tool called Quicktype, which auto-generates corresponding Dart classes after passing the expected JSON. To proceed, I will visit the API page and copy the response of the upcoming movies endpoint. Click on Test Endpoint to get a response and then copy and paste it into Quicktype. I will name the main class Upcoming Movies and copy all the generated code into the newly created file movieentity.dart. After that, I will remove the properties that are not required and all the type name properties and their corresponding enums that I can see. I'm going to create a new class responsible for mapping the network models to my domain models. To do this, I'll navigate to the network folder using the terminal as it's more convenient for me than using the interface sometimes. Then I'll create a file named networkmapper.dart. As explained before, the purpose of this class is to achieve a clear separation of responsibilities between the different layers of our application. Our domain models will cater to the specific needs of our application, while the network models will accurately represent the data returned by the API. To make the code more intuitive, I will change the name of result to movie entity. Before I begin mapping, I'll define an exception directory in the domain where I will create a custom exception for mapping errors. This exception will take two generics, from and to, representing the classes we want to convert from and to, respectively. Now, to perform the mapping, I will use a try-catch block and throw the newly created mapper exception if an error occurs. This way, we'll get precise information about the type of mapping being performed when the error occurred. I will also create another method to convert lists of objects. Inside the for loop, I'll define a try-catch block to avoid suspending the mapping of the entire list if one object fails. If this occurs, I'll log the error using the logger package. You can install it with this command. I'm going to create a class responsible for handling API requests. To do this, I will create a directory called client inside the network folder and a file called apiclient.dart. I will use the DO package to communicate with the API, so I will install it using the following command. First, I will define the DO variable and initialize it in the constructor. To communicate with the API, we need its URL, as well as the API key and API host parameters, which are specific authentication parameters for the API being used. You can find this information on the API page. I will set up the D object so that it includes these two pieces of information in the header of each request. Additionally, I will add an interceptor to log the requests made to the console so we can better understand their content and timing. Next, I will define a method called getUpcomingMovies to retrieve a list of the upcoming movies. This method will take two parameters, page and limit, which will limit the number of results and indicate which page we want to load. I will implement this request using the API documentation. I will create a custom exception to handle communication errors. This exception will contain the status code of the error and optionally an error message. If the response from the request has an error code, 400 or higher, I'll throw a network exception. If it has a status code, but it's less than 400, it means the request was successful, so I will return the upcoming movies class. If it doesn't even have a status code, something bad has happened, so I will throw a traditional exception. Finally, I will make some changes to the movies entity.dart file, installing JSON serializable and following its documentation to auto-generate the mapping code. After running the buildRunner command, the necessary methods will be auto-generated. After these changes, the error in the API client.dart file should be resolved. Our next step is to create a crucial component, the repository. Repositories are responsible for providing data to other layers while abstracting them from technical details. This means that the repository will give you a list of movies, regardless of whether it obtained them from the internet or a local database. This is an essential concept in implementing clean architecture, where the data layer takes responsibility for dealing with data, and the domain and presentation layers need not to be concerned about its origin. To proceed, create a new directory called repository in the data folder, and then create a new file called moviesrepository.dart. In this file, we will define the getUpcomingMovies method, which will obtain data from the remote API and map it to domain objects before returning it. To do this, we will need instances of API client and network mapper. In a typical clean architecture system, we would create a layer called use cases or interactors. However, based on my experience, these classes are usually empty, as the business logic for different systems usually resides on backend servers. Hence, I opt to utilize repositories directly from the presentation layer to work with data. To verify that everything is working correctly, I want to view a sample of the data. First, create a directory called presentation to handle the visual interface layer. Inside this directory, create a subdirectory called list and create a new file within it named movieslist.screen.dart. In this file, I'll define the screen where the list of movies will be displayed. To manage the state of the application and obtain a reference to the repository, I will use the provider package. If you're already familiar with a different dependency injection or state management library, feel free to use it instead. I prefer provider because I've been using it for many years, but for this example, I won't make extensive use of it. You can use the mechanism you're comfortable with. Initially, I will define a simple user interface to load the first 10 results. Later, we will improve this interface. But for now, I just want to confirm if the request and mapping are working correctly. Next, create the root widget of the application by defining the app.dart file within the app directory. I will set the screen I just created as the home screen of the app. The only part missing is the creation of all the classes and the initialization of the dependency injection, which is nothing more than creating the class tree and establishing the way to satisfy each of the dependencies for each class. But before, we are going to create a small functionality in which our app will be able to load data from a local configuration file. This will help us to create a JSON file where we will write our API key and our API host in a file that will not be tracked by Git. In this way, we can save our credentials safely. To do this, create an assets directory, and inside another config directory. We then set this configuration in pubspec.yaml so that Flutter can access the files inside the config folder. Now, create within the config folder a file called config.json.temp, where we will place the schema of our JSON as an example. The objective of this class is to have a file that acts as a template in order to create the actual file. This file will be tracked by Git, but it will not contain the actual credentials. Then, create another identical file called config.json and put your actual API credentials in it. Now open the .gitignore file and write the path to the config.json file. From now on, you can commit and push your project without fear of your credentials being in the remote repository. Now I'm going to create a model class to represent this configuration file. Create the config.dart file in the model folder in the domain layer. We will use freeze again for this. It will be necessary to run the model auto-generation again. Now open main.dart. Remove everything except the main method. Create a function that will return the config model. This function will contain the logger parameter, which will be used to log information. The job of parsing this JSON will be done inside a try-catch block. We can get the raw content of the file through this variable called root bundle that is inside the Flutter services package. We then decode it with json.decode as a map of string and dynamic. Then we simply have to return config, and in each parameter we mention the name that identifies each field. The method to load the root bundle file is loadString. If an error occurs, rethrow the exception. From now on, this configuration file must be present and valid for the application to run. Now we need to create the dependency list. Create a class called initialData, which contains a list of providers. We will use this class to store all the providers and send them to the app widget. Now create a method that returns a feature with initialData. Within this method, I'm going to proceed to instantiate all the classes that we have been creating so far. At the end of it, all I have to do is return initialData with this list of instances. In the main method, I get the initialData instance and pass it to the app widget. To do this, I have to modify the app widget to accept this input parameter. I'm going to wrap material app inside a multi-provider, and I'm going to provide it with the list of providers I just created. This way, everything below the multi-provider can access all the providers I have defined. As I explained to you before, this is the way to do it with the provider package. If you are using another dependency injection methodology, the way will be different. Now, we are going to run the app to see if everything works well. I get an error. We need to add widgets flutter binding dot ensure initialize to the beginning of the main method of main.dart. We run again and see that the list of upcoming movies has loaded correctly. Okay, now we can successfully get the data from the remote API. Next, we will proceed to improve the user interface a bit. We will make it possible to scroll infinitely in this list of movies, and we will define our database layer to create a local cache of data. Before continuing, I would like to ask you a favor. If you don't mind, could you please take a moment to give me a like and write a comment with your feedback on this tutorial? I'm always looking to improve, so any comments or suggestions will be greatly appreciated. Also, if you're able to, you can also support me by clicking on the Super Thanks button below this video or visiting my website's donation page. The link is on the video description. Thank you so much for your support. And now let's get back to the tutorial. Next, we will make some improvements to the interface. To do this, create a file called MoviePreview.dart in the list directory within the presentation folder. Here, we will create a widget that represents each movie in the list of entries. First, we will define a variable called size, which will determine the size of the movie image. The widget will take the movie to be displayed as an input parameter. For each entry, we will use a card widget that contains the movie's image, title, and release date. If the movie doesn't have an image, we will show a placeholder image instead. If the movie does have an image, we will use the cache network image package to download and cache the image. This way, if the image needs to be rendered again, it will be loaded from the cache, saving battery and bandwidth. If we need to display a placeholder image, we will define a specific widget for it. For now, we will use one of the icons already included in Flutter. Next, we will add the title and release date. We will put everything inside a flexible widget, because the title may be too long. By putting everything inside flexible, the text widget that contains the title will be able to correctly apply the ellipses. To display the release date correctly, we will need to format the date time. We can do this using the dateFormat class, but we will need to install the intl package first, which contains utilities related to app internationalization and language-related tools. We can then use this date format to format the date. Now let's go to the movies list screen and replace what's there with the widget we just created. you may encounter an error at this point, which can be solved by opening the pod file in the iOS folder and adding the following block of code. Finally, we can execute the code and see the new list interface. With the API data and a basic visual interface in place, my next step is to implement infinite scroll functionality. To do this, I will install the infinite scroll pagination package by running this command. I will then create a model class called movieslistModel.dart to manage the state of the movies list screen. This class will require the use of logger to log data and movies repository to retrieve the movies. I will create a method that takes in the current page as a parameter and returns a list of movies. If an error occurs, it will be logged and then rethrown. The method will return the list of movies for the current page, with a limit of 10 movies as that is the maximum allowed by the API. Next, in the movies list screen, I will define a variable of type paging controller to handle pagination. This controller will contain an index and each element will be of type movie. I will initialize the model I just created in the initState method. Then I will add a listener to the paging controller that uses the method we just created to get the data. In the append page method, we pass it the list of movies and indicate that the next index is the current page plus 1. Lastly, the dispose method of the paging controller needs to be called to release its resources. To display the movies, I will define the body of the scaffold in a new way using classes from the infinite scroll pagination package. The page list view receives the paging controller we defined earlier. And within the page child builder delegate, we can create the widget that we want for each movie. We will use the MoviePreview class that we created earlier. Finally, we can delete the repository from here. Once we run the app, we will be able to scroll through the movies. And we will see that as we scroll, more requests are automatically made to the remote API to get more data to display. We will now create the database layer, which will store the data obtained from the remote API to form a local cache. This will enable the user to quickly access the last list of movies that was loaded, regardless of whether they have an internet connection or not. Once this local cache is created, we will develop a system to enable users to download new data from the remote API, if it is available. As we create the database layer, we'll begin to see the benefits of the repository pattern that we have applied in the data layer. To begin, we will install SQFlite, the Flutter library that will be used to work with the database. Additionally, we will need path and path provider. The first step is to create the database entity. We will start by creating the database directory inside the data folder, and then create a new folder called entity within it. Inside the entity folder, we will create a new file called moviedbentity.dart. The goal now is to define the entity that will represent each entry in the database. To do this, we will use JSON serializable, just like we did with the network layer entities. The first thing we need to do is define the names of the fields. You will soon see why this is useful. Note that we're creating two fields for identifiers. The first will be a unique integer managed by the app, and the second is the movie ID that comes from the remote API. We're doing this because we need to apply an order to the entries in the database. So we're going to create an auto-incremental integer as a primary key that will act as a unique identifier and help us to order the data. Next, we will create a variable for each field. Using the JSON key annotation, we can give it whatever name we want. For the release date, we will use an int, which is simply the timestamp of the release date, as we cannot store dates as such in SQLite databases. We will then run the model build command so that the from JSON and to JSON methods are auto-generated. In this case, they are called this way even though they won't actually convert to JSON, but to a Dart map. We need to create the database mapping class, similar to what we did with the network layer. To do this, navigate to the database directory and create a file named databasemapper.dart. The process we'll use is identical to the network mapper, but in this case, the mapping class will be responsible for converting the database entities to domain models and vice versa. Next, we need to create a data source that connects to the database. These objects are commonly referred to as DAOs, or data access objects. Create a directory named DAO inside the database directory. We will start by creating a base DAO, from which all other DAOs will inherit. The base DAO will handle obtaining access to the database, as well as managing its creation and updating. Define base DAO as an abstract class to prevent it from being instantiated. Define a variable that contains the database version, currently set to 1, and the name of the database. I always name a database using the app identifier and its name. Define the name of the movies table, then create a protected method that returns the database instance. If the instance does not exist, it will create it. Create a private method that will handle creating the database instance. You can see how to obtain this instance in the SQLite documentation. For now, leave the onCreate method empty. The operator you see on the screen is used to return the object if it is not null, or call the method if it is. We now need to create a method that will create the movies table. This method takes an object of type batch, which we will use to execute queries more efficiently in a sequence. We define the table using the variables we have created for the table name and field names, instead of hard-coded strings to reduce the risk of typos. We can now fill in the onCreate method by getting a batch from the database and running the create query. This method will be called the first time an attempt is made to interact with the database. Next, we will create the DAO for movies, which extends from the base DAO we just created. We will first create a method to get all movies, taking in a limit and an offset to narrow the search. We obtain a reference to the database using the method we created in base DAO and perform the query, sorting the results using the auto-incrementing ID field we added. We then return a list generated from each input. We will also need a method to insert data obtained from the remote API. Create an insert all method with the following content. To insert all the data, we use a transaction, which we can implement as follows. This way of working with the database is more efficient. The last step is to apply the magic to the movies repository. Add to it the DAO and the mapping class we just created. Well, at this point we're going to apply the following logic. First, we try to get data from the database. If there are elements, then we return them. In this way, as I said before, we save having to make an API call every time we want to get data. In case the database does not contain data for the search criteria, then we make the API call as we already had before. And right after, we save the results into the database for future calls. Note that the insertion in the database is done without the await keyword. The reason is because I don't need to wait for the insert to be done. I execute it and continue with the next step, which is to return the movies. Now open main.dart and add this in the main method. This will be used to spit out in the log the operations that are done in the database, but only when the app is running in debug mode. Also add the classes we have created to the dependency tree. To show you how this cache works, I'm going to place two debug breakpoints. One when returning data from the database and another when returning data from the remote API. I run the app and as you can see, the API data is returned first. Right after, another request is made and also returned from the API. I scroll down and as I scroll down, it keeps making requests to the API and returning them. If everything has gone well, all these requests have been saved in the database. When the app is reloaded, this already downloaded data must be returned from the database. I close the app and launch it again. And as you can see, the data comes from the database. As I scroll, it continues to load from the database. If I keep scrolling down, there will come a point where I no longer have data in the database because I haven't scrolled down that much before. And then the data continues to be loaded, but this time from the remote API. As you can see, by using the repository pattern, we have been able to articulate an intelligent data layer that pulls data from two different data sources, the remote API and the local database, but making this process completely transparent to the domain layer and the presentation layer. In this way, changes in this data logic will not affect other layers of the application, thus reducing its maintenance cost and reducing the possibility of bugs. The final task for this tutorial is to create a system that synchronizes the database. Imagine a situation where you have saved all the data in your local database, but new data is added to the remote API, which you cannot see because your app is loading data from the database. Therefore, we need to create a way to detect this and notify the user to refresh the app to get the new data from the remote API. There is no specific method to do this, as it depends on the API's functionality and your specific use case. For this example, we will take a simple approach. We will compare the first record from the database with the first record from the remote API. And if they are not the same, we will display a message to the user indicating new data is available. To accomplish this task, open the movies.dart file and create a new method to remove all data from the database. Then, create a delete method in the movies repository that calls the newly created method. Next, open the movies list model and create the delete method, which should be executed inside a try-catch block in case of any errors. Now, open the movies list screen and create a method that will refresh the data. First, remove all content from the database, and then call the refresh method of the paging controller to refresh the list. Finally, call this method in a refresh indicator widget, which will wrap the page list view. I will set breakpoints to demonstrate the result. When we open the app, the data is retrieved from the database where it was saved. When we pull down the list, the refresh indicator effect is triggered, and the movies are reloaded from the remote API. This happens because we have deleted all the cached content in the database. We go back to the movies repository and create a new method to detect changes in the remote API. We start by getting the first record from the database. If the database is empty, we will get the last fresh data, and there will be no need to notify the user. We then get the data from the remote API and compare it with the first database record. If the data is the same, it means there are no new updates in the remote API. If the data is different, it indicates that the database is out of sync with the remote API, and we need to notify the user. Now, we will execute this method in movies list screen by creating a private method. We need to include everything within the callback provided by widgets binding. This is because we want to execute this as soon as we open the screen, but the widget might not have all the resources available yet. Using this callback, we can delay this operation until the complete initialization of movies list screen. To display a message to the user, we first need to get a reference to Scaffold Messenger. Go to Movies List Model and create a new method that calls the repository method we added. When we call this method, if it returns that there are new data available, we need to inform the user. We can use a snack bar for this purpose and add an action to make it easier for the user to refresh the data. To execute this action when the screen is opened, we define a future variable at the beginning of the class and assign it the value of the method we just created. Then, we wrap refresh indicator inside a future builder. At this point, I've made a mistake. I'm calling the method of the model instead of the private method of the class we just created. When we run the app, nothing happens if there are no new updates in the remote API. To test this functionality, we can temporarily change the page parameter in Movies repository so that the first data obtained from the API is different from the first database record. This will cause the snack bar to appear, informing us of the new data in the remote API. We can click on Refresh to load the new data correctly. After testing, we should change the page parameter back to 1 to ensure that everything works correctly. To complete this tutorial, I will perform 2 actions that I always do after finishing a task. First, I will execute Flutter Analyze to check for any errors in the code. Once you run it, you will notice several errors in the autogenerated classes. Since these classes are autogenerated, I will add a rule to ignore them in the analysisoptions.yaml file. To do this, you can specify the path to ignore using a wildcard to indicate that only the autogenerated files, which have the .g naming, will be ignored. Then, we have 2 more errors that we can solve in the following way. Finally, run that format dot to make sure that all files are correctly formatted. That concludes this tutorial on how to create a complete Flutter application using clean architecture. Please note that the source code for the app we created and links to various libraries and tools used in this tutorial can be found in the video description. If you haven't already, please leave a like and leave me a comment with your impressions, doubts, suggestions, or anything you would like to tell me about this tutorial. I hope this video has been helpful and that you've learned some useful things. I'll see you in the next video. Goodbye.